Hello everyone, I hope you guys can see my screen. So let me just today I'm going to discuss the lead code problem of the previous contest. Uh, yeah, you can see the contest, the weekly contest 275 is running now, but I'm not solving in not discussing any of the problems for this one right now. I would be discussing the Saturday night problem. It would be like stamping the grid, the hard problem. Yeah, this is the stamping the grid. So let me search on the internet first so that I would be able to. Okay, so let's jump directly to that UI. Yes, I'm talking about this UI. Okay, so yes, so you can see I've already solved this problem yesterday. There are 4 submissions, all are accepted. Okay, so this is the stamping the grid problem of the lead code. Its index is 2132. It is the hard type problem of the lead code. Okay, so we'd be given a m into n matrix, binary matrix. It means the cells values would be either 0 or 1. Now 1 denotes the cell is being occupied and 0 denotes the cell is being empty. Now we are given a stamp size of some height and some width, and we want to fit these stamps such that they follow the given restrictions and requirements. So these are the requirements when we are going to paste some stamp of given height and width over these matrix cells. Now all the empty cells should be covered with the stamps, and we are not going to cover any of the occupied cells, that is the cells with the values as 1, and we can put as many as stamps as we want. That is, there is no limitations on the number of stamps being used. Okay, and 2 or more stamps can overlap each other. Now this is the like quite useful requirement. Like if there is the condition that the stamps cannot overlap with each other, then this problem becomes like very much harder. I don't know why. Yes, like obviously, because when we try to like paste the stamps, and such the stamps should not overlap each other, and the positions of the occupied cells can be anything random, so it will be like very much tricky to handle that case. Okay, and also stamps are not allowed to be rotated. Okay, now if we have been given some stamps and of given height and width, then this will remain as it is. We are not going to rotate the stamps. Okay, so that height become width and vice versa. Now stamps must stay completely inside the grid. Okay, and also that if you are pasting some stamps, like all the 4 corners of these stamps must be inside the grid. They are not going to jump out of the grid any part of the stamp. And we have to return true if it possible to fit the stamps while following the given restrictions and requirements, otherwise return false. So we'd be given some arrangement of occupied cells and unoccupied cells, and we would be returning true if we are able to paste the stamps such that they can overlap each other and they are not going to cross the boundaries of the matrix, and any of the occupied cells is not going to be covered and all the unoccupied cells is going to be covered. Then we are going to return true, otherwise we are going to return false. Now you can see that yes, m into n is going to lie between 2 into 10 raised to the power 5. Okay, so we will be finding some efficient way to solve this problem. Okay, so let's first analyze this problem and then we'll be facing the coding part. Okay, so let me just open up this one. Yeah, I've solved this problem in the very first attempt. That's quite amazing. Okay, so yeah, so we'll be given some stamp, sorry, we'll be given some binary matrix. Okay, so let me just draw this one. Yeah, and suppose the occupied cells are, let me denote it by cross. Okay, now these are the occupied cells. Okay, and suppose we have been given some stamp of height 3 into 2. Okay, whose height is 3, and stamp dimensions, let me write down stamp dimensions. Okay, and we have to paste this stamp over here. So how this is going to be done? So let me write down. So its height is 3 and width is 2. So what I will do is I will just mark this stamp, height is 3 and width is 2. So one way is to place the one of the stamp over here. Now you can see that this one, this one, this one and this one followed by this and this are still empty. So we have to cover them. So we will place another stamp right over here. So it will cover these two parts. Okay, now this is done. Now but still you can see this one and this one is still empty. So we would be covering with another stamp. So it would be like this one, and another stamp would be covering this whole part. So there are 4 stamps required. 4 stamps required. But we are not interested in finding the number of stamps or minimizing or maximizing the amount of stamps being required to do that. But we are interested in finding out whether we can cover all the empty cells or not. So how this can be done efficiently? Okay, so I will write down few of the conditions first, then we will proceed further. Okay, so let me just move out to some another color. So the very first condition that you should take care for that, when we place a stamp when that cells okay, so when we place a stamp, then that submatrix where we are placing the stamp, submatrix doesn't contain any occupied cell. Okay, so you can see over here that when I am placing a stamp over here, let's say right now over here, so this one does not contain any of the occupied cells. Note that I am talking about occupied cell means the cells that are present in the original matrix. Okay, because after that, if any of the stamps being placed, we can have a choice of overlapping of some stamps. Okay, so we would be checking for that for the original matrix. When we place a stamp, then that submatrix doesn't contain any of the occupied cells. Okay, so this criteria, like this condition, solves half part of the problem, but we need to find an efficient way to check it out, all the cells being covered or not. Okay, so another concept I am going to use is like so let me write down another concept, because this is quite different from the concept of this problem, and it is like when we have been given some array. Okay, so it is like 0 1 2 3 4 5, and we have been asked that to mark all the numbers in the range 1 to 4. Okay, that all the numbers in the range 1 to 4 are present. Okay, so how will you mark all these numbers in the range 1 to 4? So there is one best way you can do is like you will maintain an array of size 6. When 0 based indexing, it will be from 0 to 5. Okay, and you have been said that you have to mark all the numbers in the range 1 to 5. So you will do this one. You will do this thing. Array of 1 will be incremented by 1, and array of the index that is present after the 4, which is 5, and it should be equal to, you will add -1 to this one. Okay, so it should be like +1 and it should be like -1. So when you do the prefix sum of this array, it should be like 0 1 1 1 1, and here it becomes 0. You can see all the numbers in the range 1 to 4 are being marked. Okay, so I am trying to explain this concept because this will help over here. Okay, so yeah, so how will you mark all the cells? Okay, so we will start with the any non-empty cell, and we will check it out whether we can place a stamp over this submatrix or not. So we will start with this cell, and we will check it out whether we can place a submatrix over here or not. So we will check it out. Yes, all these like submatrix of given stamp height and stamp width doesn't contain any of the occupied cells. Okay, so we will just mark the number present over here as +1 and here as -1. Okay, it means that all the cells which are lying in this range will be marked as true, that is 1 1. So it means that we can place a stamp whose top left corner would be this one and top right corner would be this one. Okay, so that is the stamp over here. So we will mark this one as +1 and this one as -1. Again, at this position, I will check it out whether we can place a stamp whose top left corner would be this one, like this one. Okay, whether we can place this one as or not. Okay, so we will check it out whether this region contains all the empty cells or not. Okay, so we will just mark this one. Yes, this contains all the empty cells, +1, and here is -1. And again, we will try to check out for this top left cell whether we can place a stamp whose top left corner would be like right over here or not. So you can see this entire sub matrix would be containing all the empty cells. Yes, we can place that, so we will mark it as +1 and here as -1, and again over here +1 and somewhere over here -1. Whether we can place a stamp over here, you can see this will cross the boundaries of the cells. Okay, so we will not be considering this one. Now we are done. So we will find out the prefix sums for every row. Okay, so when we try to find out the prefix sum of the every row, you will find something like this. That should be +1, and yeah, so you will find like let me just erase it and write over here. Okay, so you will find prefix sum 1 1, and it should be like 2, because when one of the top left stamp will be placed over here, it will be incremented by 1, and here it will be also incremented by 1, but here it will be decreased by 1, and after that we are not interested. And again here you will find 1 2 1. Okay, now it means that this is the least row for which we can place the stamp. Okay, so we will be trying to find out that least row for every column. Okay, so I'm again writing it out. Finding the lowest row for every column where we can place my top left corner of the stamp. Where we can place my top left corner of the stamp. Okay, so what we can do is where we can we are not writing down the top left corner of the stamp, where we can place the stamp. Okay, so this should not be we can place the stamp. We can place the stamp, because I'm writing this one a condition also, because suppose you are at this cell. Okay, suppose you are at this cell. Okay, so the value is here is not the value is over here is strictly positive, so it means that the stamp that you can place over here can be extended right up to there. Okay, so you are interested in that thing only. Okay, so the top left corner can be over here. Okay, but we are interested to check it out how much we can extend, like how much if we put out a stamp, it will cover right over here. Okay, we are interested in only that part. So our problem boils down to the simple condition is, first we will check it out, place a stamp, that is we can place a stamp where the submatrix doesn't contain any of the occupied cells. And how will you fill out the stamp? So for every column, that is if you are at this column, you will check it out what is the least row where there is some positive integer. You can say there is some positive integer right over here. Okay, so then you will place a stamp over here. Not placing the stamp, you will be just marking out the cells. That is, this cell would be marked, this cell would be marked, and this cell would be marked, because here is some positive integer. It means that some stamp will be placed over some cells such that this cell will be covered, and when this cell will be covered, its entire entire column just beneath this row having the height as 3, you can see this one will be covered, and all the cells which are which are positive, you can see this one and this one would be already marked as true, and that is we can place a stamp such that it will cover this cell. And again, when we are at this cell, we will mark this one like the downward 3 rows. Note that 3 is nothing but a stamp height, and when we are at this one, we will mark this one and this one, denoting that yes, we can cover all these empty cells with the stamps when the stamps are being placed somewhere over whose top left corner would be here or top left corner would be here. Okay, so let us take some another example which will clear it out more. So can we take from this one? Yeah, we can take from this one. Okay, so there would be something like this. So this is a cross, this is a cross, this is a cross, this is a cross. And what is the stamp height and width? 2 into 2. Okay, so 2 into 2. So it means that we are going to place a 2 into 2 stamp. So we will check it out. Can we place a 2 into 2 stamp over here? No, we cannot, because it will cover the occupied cell. Can we place an empty stamp over here? Yes. So we'll mark +1 over here and -1 over here. So it will be like filled with 1 1. So can we place a stamp over here? No, we cannot. So can we place a stamp over here? Yes. So it will be +1 and somewhere -1 over here. So it will be like 1 1. Can we place a stamp over here? No, not. Okay, so let's try to here you are going to find these two positive integers over the matrix. So what we are going to do is, when we are this one, like find out the, when we are this column, we will find out the lowest row where the integer is positive. You can see the lowest row where integer is positive is this one. We'll mark all the k, like a stamp height amount of cells to the down of it as true. So we'll mark this one and this one. And for this case also, for this column, we'll mark this one as true and this one as true. And for this column, you will say that the lowest row where it is positive, you can see the positive is lying over here. Note that I'm talking about the lowest row would be like this one. Suppose some positive numbers come over here, then some cross, and then some positive numbers come over here. So for this consecutive segment, the lowest row would be like this one. And for this consecutive segment, the lowest row where some positive integer is lying would be this one. So then I will mark this one and this one. Note that if some positive integer are already there, it means that this row is already marked as true. We can place a stamp. Okay. I'm talking about the lowest row because suppose that if we can place a stamp to this lowest row, then to the all the stamps, like to the all the places that is just right up to the current cell, we can place a stamp, obviously. So this will be marked as true and this will be marked as true. Now we are done. Now we will check it out whether there exists some empty cell in the original matrix. Okay, and still it is not marked, then we will return false. You can see this is not marked, this is not marked, this is not marked, this is not marked. So our answer in this case will be false. Okay. Now there is one more tricky part. How do we calculate this one? Place a stamp when that submatrix doesn't contain any occupied cell. I want to hear from you guys that how you check this condition, but still I would give some hint to consider to find out that part. Okay, so that part would be quite much easy. Suppose you have some matrix. Okay, and you have been interested to find out whether there exist any of the occupied cells or not in this region. So what you would be doing is, like, you would be finding out another matrix. Okay, trying to find out another matrix where at a particular cell I comma j, like suppose I'm talking about this cell I comma j, you have the data of sum of all those grid values of all these positions, like this one. If you are at this cell, you would have the data of sum of all the grid values, cells values up to this ith row and jth column, that is this entire submatrix, whose one end point would be always 0 comma 0. Okay, so suppose you are at this cell I comma j, then you have the grid values of all those cells up to the ith row and jth column, that is this one, whose top left corner would be this one. So how do you answer the submatrix whether this submatrix contains all those empty cells or not? Okay, so you would find out the prefix sum, that is the value present at this I comma j cell. Okay, so it would cover all these values, like it would cover all this value. Okay, but we are interested in only this value. You can see this one. So we will be subtracting out all this value and we will be subtracting it out all this value. Okay, so if you're not getting it, let me choose another color. So you will be just subtracting it out this part, and you will be subtracting it out this part. Okay, from this entire part up to this I comma j, that is from this part. Okay, note that this part, this cell is subtracted twice, so you need to add that. I am leaving it up to you guys to solve this one. This is quite an easy one of idea of prefix sums in a matrix. I hope you can do that. If still you can't approach it, then I will be I will be helping you guys, obviously. So let's move out to the coding part. Okay, so I would be just showing it out the code because it's quite a bit long. But yes, I've tried to explain this everything. Okay, so this is the this sum matrix will help in checking the region of empty cells, as I've already said, because this entire part, you can see two for loops, is helping it to find out for a particular cell I comma j what is the prefix sums up to this cell I comma j, like up to the ith row and jth column. And there will be a matrix that will store the data whether we can apply the stamp within this region or not. So this is basically this part. I'm applying for a given array, I'm applying a +1 and -1 operation. Okay, so what I've been doing, if the grid is non-empty and if we can place a stamp, I plus stamp height is going to be less than equal to n, j plus stamp width should be less than equal to m, and okay of this. Okay, then we can increment this cell I comma j, and if the j plus stamp width should be within the bounds, I will decrement it by -1, that is +1 and -1. Okay, all the cells within this region will be marked as true. Okay, now what is this okay function? Okay function will check it out whether the submatrix from this one x1 comma y1 to x2 comma y2 contains all the empty cells or not. I'm leaving up to you guys to understand this one because this is quite a bit very much easy. Okay, so we'll find out the prefix sums for every row. So it will contain the cells values like this one. You can see over here like 1 to 1 and again like 1 to 1. It will contain these values. Now all the positive integers will always satisfy that yes, we can place a stamp over here. But if that reason is non-positive, it is 0, then we will check it out whether we can place a stamp or not. Okay, so you can see what I've done is like if the grid is grid is empty and matrix contain a positive value, this will be marked as true. Like yes, we can place a stamp over here. But what about if we place a stamp to the lowest row after some consecutive positive integers? It will extend the stamp height to some lower rows also. That is if like this one. Yeah, when you want to place a stamp over this position, you can see it will cover this part. These regions are initially empty and it will be filled now. So we will be considering that for every column. Okay, so you can see I have started for every column, and if the grid is already occupied in the original array or the matrix contain a positive integer, then we will just skip it. And what we will be doing like, okay, so if the matrix containing non-positive, okay, so this is a non-positive, so I will skip it. So what what I'm doing is like finding out the last row where we should place a stamp, like top left corner of the stamp or any of the stamp, we don't care, because if you place a like this is a positive integer, because then some stamp would be covering all the stamp height rows to the down of it. So I will check it out. K is less than n, matrix of kj is some positive, we will increment the k. So now you can see k after we are doing with k minus minus, now k contains that position of the lowest row where there is a positive integer. Now I have taken down as a stamp height. I will mark all these down rows as true, because we can place a like there is some arrangement where we can place a stamp and it will cover all those rows. Okay, so you can see mark of k plus plus j as true, and I need to do this one because to satisfy the looping condition. Now finally we'll check it out. If the cell is empty in the original array and still we haven't marked it, then we can return false, because this is not like we are not going to find any optimal way to do that. Otherwise return true. So this will give you all test cases passed. I hope you guys have enjoyed this video, and if you still have any doubts, do let me know so that I can help you. Thank you guys for the watching the video, and don't forget to subscribe.